because my computer doesn't have a lot of storage. Okay, hi everyone. Welcome to our webinar called Astronomy in Any Classroom. So today I'm going to be going through some of the resources that Discover the Universe offers. And if you have questions, you can stop me at any time. And yeah, just interrupt me, that's fine. Either in the chat or verbally, I'm good with anything. Okay, so you can all see the slides, right?
That's correct. I'll just mute myself after saying that, though.
Thank you. Thank you. So, okay. So a little bit about Discover the Universe, what we are. So we are an astronomy training program led by Canadian astronomers dedicated to helping educators share the wonders of the cosmos. So we understand that most teachers are trained in either the general sciences or just general knowledge. I suppose if you're an elementary teacher, but if you're a high school teacher, then either like general science or either physics, chemistry, or bio, but not really so much on astronomy, even though that's something that you have to teach. So we know that can provide a little bit of tension or maybe a little bit of anxiety if it's not something you're super comfortable with. So we want to help you bridge that gap, knowing that there's not like a lot of astronomy resources out there for teachers. And we are Canadian. We're fully bilingual. Everything we have is in both English and French. And yeah, we try to cover the curriculum across the country from coast to coast. And then a little bit about me, since you asked. My name's Alicia. I used to be a high school maths and physics teacher. I've taught both in Ontario and in the UK because there are no jobs in Ontario. But I quit that because teaching was too hard for me. And now I'm getting my PhD in astrophysics at University of Toronto, in the Canadian Institute for Theoretical Astrophysics. I'm in my 4th year. And I study the gas that falls into black holes. So you may have seen this picture of a black hole. I study this orange stuff here. That's gas. I work for Discover the Universe in my spare time because I'm still really passionate about education and science communication, even though I quit teaching. My role is an education specialist, so I help to develop the resources that I'm going to talk to you about today. So the main thing I want to get across to you all today is that Discover the Universe, although we are branded as an astronomy sort of training program, we actually have resources that you can use across science, not just in astronomy. So if you have really eager kids that love astronomy, or you're just looking for sort of a different twist on one of your lessons, we can probably help you bring some astronomy into your classroom in other classes than astronomy. So looking through the curricula across all the provinces, I found that these topics come up pretty much in all of them. So earth science and geology, weather and climate, the space unit, of course, a flight unit, motion, chemistry, electricity and magnetism, and waves, light, and optics. So these kind of show up across Canada. And we have resources that touch on almost all of these. So I'm going to try to go through, for each of these topics, the resources that Discover the Universe can offer you to help you teach these to your students. Yeah. So if you want these slides, here's a QR code. So you yeah. So if you want the slides, go to that link. Okay. Are there any questions before we get started? Otherwise, I will jump right into the content. Okay, fair enough. So the first topic that we'll be considering is earth science and geology. So the ways that earth science and geology connect to astronomy, um, the Earth, of course, is in space. So that's one way to bring astronomy into your geology units. But also exoplanets. So a lot of what you study in any sort of earth science context is able to be related to our studies of exoplanets in astronomy. So a lot of like earth science is studying like the atmosphere, like the composition of the earth, like why the earth's surface looks how it does with the valleys and the mountains and volcanoes and etc. So all of that, what we know from Earth, we apply when we study both planets within the solar system and exoplanets, which are planets outside of the solar system. Um, yeah, so for example, there's a moon, which isn't a planet, but like some of the moons of like Jupiter and Saturn have sort of like cracks in their crust, which is lets us know that they must have some kind of like tectonic motion occurring underneath the surface that is like producing those cracks. Or Mars has a lot of little features that look like dried up rivers from like erosion that looks like there may have been water on Mars's surface. So those are examples of within the solar system, but we use that for some exoplanets as well. We're not really able to resolve them quite as well as we can resolve solar system planets right now, but yeah. And resources that we have to help you teach these. We have this whole suite of resources called exoplanets in the classroom. So I'll explain what those are to you now. And by the way, all of the resources I'm going to be talking about today are like available completely for free on our website, which is discovertheuniverse.ca. Or if you are French speaking, um, I am not, à la découverte de l'univers.ca. So, okay, exoplanets in the classroom, like I said, it's a suite of educational resources that include things like ready-made presentations, like for you to give as lessons to your students, or for you to use to try to get a little bit more understanding of what exoplanets are and what we think about them as astronomers. There's a glossary and a frequently asked questions page. There are activity kits for both primary and secondary students, which include like basically like full activities you can run in your own lesson. So one of the things we have are these flashcards here. These are just three, but we have for many different exoplanets and planets within our solar system, like Saturn is right here. Just giving you like some facts about that planet. So these are like flashcards that you can print off. And some of our activities are related to these flashcards. So there's a contest that we are running in the winter called In an Astronomer's Shoes, where you basically take these flashcards, you choose an exoplanet, and then you write like a mock observing request for a telescope like JWST saying, I want to observe this planet and this is why. So yeah, activities like those. And that contest we will be running in February, I believe. So if you're interested, stay tuned. Your students may win a conversation with me if they would like that. We also have videos for you to share with your students from real exoplanet astronomers, just lots of resources. So that's a very in-depth resource that we offer at Discover the Universe. Okay, moving on to the next topic, unless there are any questions about earth science. Okay, so the next topic is weather and climate. So the ways that these connect to astronomy and how you can bring astronomy into these seemingly not astronomy related courses. Again, exoplanets. So a lot of the weather on Earth, we try to observe on planets in the solar system or external planets. So like Venus has like a very, very thick atmosphere, things like that. And also the sun. A lot of the weather on Earth is caused by the sun. So resources we have to help teach those. Again, exoplanets in the classroom because, atmospheres are a big thing when you're thinking about exoplanets, like what their composition is. Like, is it like a gas planet or like a terrestrial planet? Those kinds of things. And then these two new resources I haven't talked about yet. We have a climate app and a solar cycle activity. So I'll go through what both of those entail. The climate app is really, really cool. It is more geared towards secondary students, but not unattainable for primary. So basically it helps your students understand like what the greenhouse effect is interactively. So it's basically a simulator, and then you put in different parameters like how like bright is your star. So like you could simulate Earth's greenhouse effect, or you could simulate the greenhouse effect on like a different planet like Venus or something. So you say like how bright is the star. The opacity means like how well does your atmosphere trap in infrared light, which is what heats up the planet. And the planetary reflectivity is like how well does your planet like reflect off that light. So there's also like a more advanced version if you want to play with even more parameters with your students, but it helps you get a feel for the greenhouse effect on our planet, other planets, what'll happen in the future if things keep getting worse with how they're going. So I think this is one of our coolest activities. Yeah. The solar cycle is another activity I really like. It is also more geared towards secondary students, but maybe some like upper year primary could play with it too. So it's an inquiry-based activity guide. So there's another web-based tool here where you can access real astronomical observations of what's happening on the sun. So you've probably heard that the sun goes through a solar cycle. Sometimes it's very active and sometimes it's less active. When it's very active, we get a lot of solar wind coming towards us, which is when the sun flares, sends charged particles our way, and then we get aurora. So we're coming out of a peak of the solar cycle right now, a really active session, which is why we've had a lot of aurora over the last year or two. But in order to measure that solar activity, one thing you want to look for are sunspots, which are these dark spots on the sun. They occur because the sun has a magnetic field, but sometimes if the sun is in an active session, the magnetic field is really, really strong and sort of blocks the convection of like the gas coming to the surface of the sun. So little spots on the sun cool down because the hot gas from the center of the sun isn't making it all the way to the top. And since they're cooler, they appear a little bit darker. Um, so that's why you get like little dots like all of these. If you can see my mouse, I hope you can. So you're basically loading in astronomical data to try to find these sort of like regions where there is activity. And it helps answer questions like, why do astronomers observe in multiple wavelengths? Like, why do we look at UV light and infrared light and radio light and all these different kinds of light? And how are solar activity patterns on the sun tied to what we see on Earth, things like the aurora? So that's a very fun activity because you're using like real data. Pretty cool. Okay, that's it for the weather unit. But moving on now to space. Before I keep going, are there any questions? Okay, so space. This one seems pretty obvious how you connect it to astronomy, but mostly in the curriculum across Canada, it seems the focus is mostly on the solar system and stars and how they evolve. But some provinces kind of go a little bit into galaxies and also cosmology, which is the study of the history of the universe. So we have lots of resources that you can use in the space unit. Basically, any of our resources you can apply to the space unit. So exoplanets in the classroom and the solar cycle are activities I've already talked about that you can use. But now we have three new ones. So solar eclipses looking up in the solar system. So I'll go through those quick. Solar eclipses. So in 2024, we had a huge eclipse across Canada, like a total eclipse. And some of you may have come to our eclipse training and may be familiar with me already. But we developed so many resources for that eclipse that are still useful for any future eclipse or any partial eclipse because they will happen again. And all of that is completely available to you. So here's a screenshot of some of the activities we developed. I really like these activities because a lot of them are interdisciplinary. So for example, like sort of these modeling eclipses, I guess you could consider that kind of artsy or kind of mathy because you're looking at scales. Calculate the eclipse is a math activity I developed where you're calculating like the angles between like how much like the sun So an eclipse happens when the moon comes in between the sun and the earth, and everything is lined up perfectly for the moon shadow to fall on the earth. And so you're calculating like how big that shadow would be on the earth using like trigonometry and stuff. So that's a math exercise related to the eclipse. Really cool for a trigonometry unit if anyone teaches functions. The eclipse investigation is an interdisciplinary activity, but with history or English or language arts, where you're basically looking at, like sort of writing like a newspaper article on the eclipse and what it's meant for different cultures throughout history. So that's a really cool little investigation. We have tutorials for how to use online simulators. Like there's an eclipse simulator, but there's also something called Stellarium, which is a really great resource if you haven't heard of it before. I think one of our team gave a webinar on how to use Stellarium in September, and that should be recorded, so you should definitely check out that if you haven't yet. And luminosity drop, that's more of a physicsy um, activity where you're sort of measuring how much darker it gets when you're in the path of totality during an eclipse and how quickly the brightness drops. So all of these are ready-made activities that are scaffolded so you can use them for different age groups. We have recorded webinars to help you and your students learn about eclipses and eclipse safety, since that is a topic that is in most curricula across the country. So yeah, tons of resources for eclipses. Our next activity is, I think, probably our most popular. It's the solar system. So it's sort of it's like it helps you calculate the scale of the solar system because that's very, very hard for children or even me to envision. So you basically, it tells you if you wanted to compare like the sizes of the planets, what kind of household item you would need to do that. So if you had a bus around and you considered that how big the sun was, then Mercury would be the size of a plum, Earth would be a grapefruit, the moon would be a grape. Jupiter would be the height of a child. I'm not sure what aged child, and maybe or maybe not, that is a household item for you, but everything else should be available to you in school, probably also children. Yeah, so that shows you how big the different planets are relative to each other, but then it also shows you can center a map on some city. I chose Halifax because I was just there about a month ago. It's very pretty. And it shows you how big the orbits of those planets are. So I think this is Mercury, Venus, Earth, Mars, and then Jupiter's way out here. So basically all of Halifax is enclosed within Mars's orbit. Yeah, so that's a really interesting activity to show students like the scale of the universe. And one of our most popular ones for sure. Finally, we have Looking Up, which is several activity guides to help students or yourself learn how to look for things in the sky, things like phases of the moon or like constellations, things like that. It is scaffolded again for all grade levels, and we do run a challenge starting in a couple weeks where we encourage teachers to do these activities with their students throughout the winter. So look out for that challenge if you're interested as well. That's it for the space unit. Are there any questions before we move on to the next topic? Okay, so there is a flight unit usually in grade 6 for most provinces. And that is easy to incorporate astronomy into because aerospace engineering, for both making airplanes, but also making things like rocket ships, like the space shuttle. And I'm sure one of these is the Saturn V. I am not super familiar with rockets. I am not a rocket scientist. But yeah, so everything you learn in the flight unit can be applied to aerospace engineering, which a lot of students I think are interested in right now. And also what we astronomers call instrumentation, which is the development of telescopes and how we see things in space. So here at U of T, we have one group that basically takes a huge weather balloon and they attach it to like a really big telescope and then they like let it go and it goes up above the atmosphere and then you can like take really pretty pictures in space. So that you need to understand a little bit about flight for that. for getting like the telescopes up into space. We don't have any resources related to flight yet, but we are aware that it is like a hole in what we're offering. So maybe there will be something in the future. The next topic is motion. So this is something that I suppose mostly comes up in physics in grade 11 or 12, but also, when you're teaching the younger years, motion also comes up. So that's actually really related to astronomy, even if you wouldn't expect it to be. So astro connections to motion, orbits, of course. So if you are a physics teacher, you talk a lot about like Newton's law of gravitation and how things orbit around each other. So that's an obvious connection to space. Also collisions, if you ever talk about collisions, that happens all the time in space. That's how we get things like craters, and why the moon and Mercury look the way they do. And then gravity is a huge connection between astronomy and motion, because like I said, gravity kind of dictates a lot of motion, like why things fall back down when you throw them up. So the resources we have related to motion, the solar eclipse activities are really related to sort of orbits, right? Because eclipses happen because of orbits. So if you're ever talking about, circular motion or orbits, you can bring in solar eclipses. And currently I am developing a set of resources for black holes, which is not in most curricula, but is a topic that a lot of students are interested in. So I'm trying to work on resources for that. It's not ready yet, but hopefully later in 2026, that will be available to you. Chemistry is another topic that shows up, of course, in every province. And it has a lot of astro connections, believe it or not. So, one very obvious way that chemistry connects to astro is the composition of the universe. So you might have heard that the universe is basically 75% hydrogen and 24% helium. And I know that adds up to 100, but it's a very small amount. It's like 1% of everything else. So that is, of course, because hydrogen and helium are the lightest elements and they're the easiest to make. So that's a really cool tie-in for chemistry when you're going over like the periodic table. Spectra. So takes a little bit of an explanation if you haven't heard of it before, but basically, every element kind of gives off different colors of light when its electrons get excited. So you can basically take a picture of the light coming off of, say, a star, for instance, and based off what colors are or are not there, you can tell what elements are in that star or gas cloud or anything in the universe. And that's how we figure out what different objects in the universe are made of, like be it a gas cloud or a star or something else. We look at what colors are and are not there. And that ties in really well to grade 11, 12 chemistry when you're talking about, electron orbits and how they transition between the different orbitals. Fusion is something that is talked about either in chemistry or physics, depending where you are. But it basically means when you have two smaller elements like hydrogen, and if they bump into each other, like if you have four hydrogens, you can make one helium. That's what happens in the center of stars, and that's how stars stay alive. That's how they keep themselves from collapsing, because they're constantly making energy through fusion in their cores. Particles and light. This is a little bit more advanced, but if you do teach grade 11 or 12 chemistry, you are familiar with how electrons, when they jump up and down between orbits, give off or accept light. And then one that's a little bit maybe not as obvious is life in the universe is very related to chemistry. So on Earth, anything that is, alive has carbon or is related to carbon. Like carbon is very important for life on Earth, and things like H2O water is very important for life. So these are elements or molecules that we look for when we're looking at like exoplanets to say if they could or could possibly be habitable. So that's a really interesting connection between chemistry and astronomy and biology, I suppose. Oh, I've lost our resources slide for chemistry. I must have accidentally deleted it. I'll add that back in. But the resources we have connected to this, the main one is exoplanets in the classroom. So the exoplanets in the classroom, like I just said, you want to look for different molecules and elements, and if they appear in those atmospheres to see if there is the possibility of life. I think that is the main connection to chemistry. Sorry about that. I'll add that slide back in. Not sure where it went. Electricity and magnetism is our second to last topic. Are there any questions before we move on? Okay. So, oh, here's the chemistry resources. The slides were flipped, my bad. So yeah, exoplanets in the classroom is a good resource for chemistry. So that contest I was talking about where you're picking a planet that you might want to look at through a telescope. One of the questions is, could this planet support life? Why or why not? Why not? And that involves some understanding of the elements that support life. And then the black holes resources that I'm working on should be have some tie into chemistry as well when I am done with them. Back to electricity and magnetism. So electricity and magnetism are huge in astronomy. Basically, electricity and magnetism are the reason we have light, and all of astronomy is studied, almost all of astronomy is studied through light. So it's huge for us. But one thing that's really important are magnetic fields. That's actually the most important thing for me in my own research. And lots of different things have magnetic fields. The Earth has a magnetic field. The sun has a magnetic field. Stars have magnetic fields in general. Things like neutron stars have magnetic fields. Black holes don't necessarily have magnetic fields themselves, but they have magnetic fields around them. Even just gas in galaxies has magnetic fields. They're everywhere. It's very important. And then the aurora are a direct result of Earth's magnetic field, which I can explain a bit more if you are curious. So yeah, easy ways to connect to astronomy there. Everything has a magnetic field, basically. So the resources that relate to magnetic fields and electricity are the solar cycle. So like I said, the solar cycle, that was the activity where you're looking at sunspots and how the sun goes through its cycle. That is completely because of magnetic fields. And then we have a new resource that I think has just made it onto our website, but it's still a little bit of a work in progress. We're still adding a few more things to that section of the website, but it's called Cosmic Foundations Magnetism. And what this is, it's a set of many different activities for K through 12 related to electricity and magnetism. So examples of some of the resources on there, like it starts as early as like what things are magnetic, what things aren't magnetic, what happens if you stick two magnets together, developing, like making your own compass at home. That's a really fun activity. There's, what else is there? The most advanced activity and the one that I found the funnest is you can make an electromagnetic train. So what that means is if you have a copper wire and a battery and a couple of really strong magnets, you can kind of push the battery around in a circle. It's very fun. And all of it is due to electricity and magnetism. So this activity kit is unique because it doesn't just have the activities in it, but it also has a lot of background information for teachers on like the physics and the science behind the activities. So yeah, really great resource. We're definitely really proud of it, but it is still a work in progress in terms of what's on the website. So I guess I just explained this, but these are the sort of activities offered in that Cosmic Foundations package. So what is a magnet, magnetic attraction and repulsion, exploring magnetic field lines. So that's when you take like a bar magnet and you sprinkle iron filings around it, making your own compass. And then this is the electromagnetic train I was talking about. If you stick these magnets on the end of the battery, it like pushes itself through the copper wire. So if you're like a grade 12-ish physics teacher, that's a really, really fun activity. So we also have like fully developed lesson slides for you to use on all of those concepts. And then our last topic, waves, light, and optics. So how that relates to astronomy and how you can bring astronomy into that unit. Of course, light is a wave. Um, sometimes it's a particle, but light is a wave, and all of these different kinds of waves are light. So X-rays that you get, at the doctor, that's light. Ultraviolet is the light that comes off the sun that hurts us. Visible light, like the colors we see. Infrared is sort of related to heat, or like if you have a remote control, and you like point it at something, it's sending an infrared light wave. Microwaves, like what heats up your food. Radio waves for the radio, or if the radio is too obsolete in this day and age, I think your cell phone also goes off radio waves. Yeah. And then gamma rays, which are really, really, really energetic light waves that are dangerous. So avoid those. So that's all related to waves, of course, and light and optics. Gravitational waves. So these are not light waves, but they're sort of waves through space, or what we call space-time, that happen when two really dense objects, like two black holes or two neutron stars, are spiraling in and about to collide. They send out these ripples that astronomers can measure in very clever ways. So that's related to waves. Very cool topic. There are also sound waves that happen in space all the time. So there are like pressure waves that travel through gas, and sound is a pressure wave. Again, I talked about how particles and light kind of interact with each other. So when you're talking about light, you can talk about that sort of thing. And then the most obvious one, of course, is telescopes. So I think most provinces have an optics unit where you're talking about like lenses and mirrors and refraction and reflection and so on. Of course, all of that is very, very important in creating a telescope. So you could try to relate that back. So the main resource we have related to waves, light, and optics is a second half of our cosmic foundation. So I just talked about magnetism. This one is light and optics. So it has, again, all of the same background info to help you understand a little bit more about these physics, science concepts. It has fully developed lessons and activities. The activities include learning about color, like why do things appear different colors? What happens if you mix like red and yellow light? Those sorts of ideas. Reflection versus refraction, concave and convex prisms, how you see with your eyeball, and diffraction, which is one of the most exciting things for me anyway. So yeah, all of these activities are like fully fleshed out and available for you. We have a few other resources that don't really fit into any of the topics I've talked about so far, but we have this really cool thing called Astro at Home. So it was a bunch of people, not just discover the universe, but like partnered with different astronomers, like through University of Toronto, or even astronauts, like real Canadian astronauts, basically just talking for about 40 minutes about several different topics. Basically any topic you could think of related to space, including the scales of space, planets, moons, the night sky, aliens, black holes, gravitational waves, gravity, stars, telescopes, the auroras. An actual interview with this astronaut who I think is called David Williams, and many more topics as well. We also offer events throughout the year, both online and in person. So this is a screenshot of some of the online events we have coming up or just past, but the events that we offered through the fall. So our director is leading this discussion group called Spaceship Earth, where she's sort of talking about how, we all live on this one planet and how that can, just trying to like bring that sort of idea back into your classroom with your students, trying to remember like we're all in this together. Um, Something that new that we're starting that already happened for this semester, but next semester we'll have another one, are office hours. So it's basically one of our staff will be in a Zoom room like this, and then you can just come and any sort of astronomy question you have, if you want help trying to understand something or trying to help explain something to your students, we will just help you. We're just there. The webinar that's running right now, and then that challenge I talked about. So, the looking up challenge where you're trying to find things in the sky with your students. So we have, this is again just for the fall, but we have lots of teacher training. We have lots of webinars like the one you're at right now. The office hours we'll do, I think, twice a year or so. The contests like this looking up challenge and the contest that I mentioned that's going to be running in February, and then these discussion groups. So we'd love if you'd attend some of our other events. We also do on occasion have in-person events. Like last May, we ran an in-person teacher training in Toronto. So if you are based in the GTA or close to, that's something you can look out for. Yeah, so that kind of concludes my sort of like lecturing portion of the day. I just really wanted to get across to you that astronomy is just such a cool science because you cannot do it without all of the other sciences. Like you need physics, chemistry, motion, all of these concepts to do astronomy. And that's why I chose to study it because I think that's really exciting. So you can use all of these astronomy resources in other classes as well and in other lessons, especially if you have really space interested students. And we have a lot of resources to help support you in doing that. We do still have like 15, 20 minutes left. So what I was hoping to do, if you're interested, is we could pick one or two of these resources and we could like look a little bit deeper into them together. So before we do that, does anyone have any questions about anything we've talked about today?
Yes and no.
Okay, go ahead.
No, no, I don't really have a question. I just think it's great. Thank you.
Awesome. I'm glad you liked it. Is the material available in French? Yes, everything is in both languages. The only thing that I think is waiting on translation is that cosmic foundations material, but everything else should be in both languages. Um, okay, if there are no questions, does anyone want to choose bienvenue? Does anyone want to choose? That's as good as my French gets. Does anyone want to choose one of these activities? We can look a little bit deeper into it. Or I could choose one, but I'd rather cater to you.
Maybe Masha should pick one.
Go ahead.
I liked every single one, sorry, and it was the one that I really enjoyed black holes, and then that was the one that you guys haven't had a lot yet on, so
That's
I was
on me, not the rest of the team. That was my little project and it's in the works.
yeah, yeah, that's okay.
Was there anything else you wanted to look at or anyone wanted to look at
I liked all of them. I'd be happy to do any which one that you like.
that I like? What grade are you in?
I'm in grade 11.
Oh, cool.
I'm in, I mean, yeah, but the thing is that our school is slightly, I guess we also still like do astronomy like in at least in our class because I'm in IB, so our physics talks about space as well, which I'm very looking forward to.
That is cool. That is exciting. IB is great. That's great that you can do that. Okay, I will choose. Let's do eclipses because that's what got me hired at DU. So I have a little special place in my heart for it. So we'll go through that. Um, don't mind all my tabs. Let's go to discover the universe.ca, resources. All the classical foundations are fully up. That's so exciting. Which one did I say? Oh, I said we'll do solar eclipses. So let's choose one of those activities. Where are they? So you can see like all of our, well, most of our resources also come like with a bunch of info for you. We'll choose. Well, my inclination is to choose the math one, but I know not everyone is a fan of math. So let's choose one of the model ones. Let's do, sure, we'll do this one. So this one's actually really cute for all ages, not just little ones, but definitely also little ones. So you basically want to take like sort of like an earth ball and then a smaller ball that would be your moon. And then you kind of go outside in the sun and you show that if you hold the moon in the sun's light, it'll cast a shadow on the earth ball. So this is our director, Julie, holding the earth, and someone who I think maybe her son, but a student holding a moon. So it doesn't actually have to be looking like the earth and moon. They can be just different sized balls, like a beach ball and like a baseball, some ball. So you can see if you hold it in the direction of like the sun, you get like a little shadow on the earth. So this is kind of just help students understand physically what's happening that's casting the shadow. And you can also get them to, I think it's really funny if you get like one student to be the sun, one student to be the moon, and one student to be the earth, and you make them like rotate around each other and like spin, they find it really fun. Um, Even like high school students think that's really funny if you can like get them into it. So that's one activity. I could choose another.
That made me think of something else along the same lines.
Yeah,
People get confused by a simple thing to us about the phases of the moon.
yes.
And the activity would be using a dark, semi-darkened room, a bright light, and you could use styrofoam balls and have people behave as the Earth and hold the moon out.
Yeah, I definitely did that when I was a teacher myself, and it was super fun. So if you have, I think we might have a resource like that somewhere, I was told. I'm not sure under which thing it's categorized, but that is a really fun activity. Yeah. It
It's,
even
but
helps me
it's,
understand.
it's a simple thing that confuses a lot of people.
Yeah. Yeah, definitely is kind of confusing. Like a lot of people think the phases of the moon are because like, oh, the earth is like blocking the sun, but it's really just that the moon is kind of out of the way. Yeah, that's a really good point. Thank you for bringing it up. Well, we can look at one of our new resources. We'll go to Cosmic Foundations and see what's available there. So Lori Russo-Neptun is an Indigenous faculty member here at the University of Toronto, and we partner with her a lot because she really cares about pedagogy, and she's also just like really cool and really smart. So she helped us develop these resources initially for like Indigenous groups across Canada, but now we're sharing it with everyone. So these are all of the activities we've created along with the grades that that activity is suitable for. Um, so one of them, does anyone want to help me pick an activity, either from light and optics or magnetism? From where did the list go? I'll go to magnetism because that's the one that I helped with, so I'm more familiar with it. Um, where's our list of activities? Here. Do any of these activities draw your attention? Okay, I'll choose the compass one because it's cute. Where's the compass? Go to compass. Nice. So, okay, so yeah, it starts with like the key concepts. So like, what is a magnetic field? What is the magnetic poles? How is it different from the North and the South Pole? Because they are different, they're tilted. And here's a little video of Lori showing how to make this compass, but it's really cute. You take like, you need some kind of magnet, a real compass just to check your work, something to hold your, this isn't the right one. Exploring magnetic field lines is activity 4, sorry. You need, where are the materials? You need a magnet, you need a needle, like a sewing needle, a small bowl of water, either a piece of paper or cardboard or like a cork even, something that floats. And then writing materials to complete the worksheet, but you don't really need that to do the activity. So you basically you take like the needle and then you like take the magnet and you like rub it on the needle so it becomes magnetized. And then you put the needle on the piece of paper or the floating thing in the bowl of water, and then you like let it go and it points. And then you can check your work with your compass. And it's really cool. It actually works. I wouldn't trust it if I was like lost, but it does work. Yeah, so those are a couple of our activities. I guess we're already at 7:50 now, so you can absolutely feel free to go. Thank you everyone for joining. If you do have more questions about our resources or space or Masha, if you had questions, I hope I'm saying that right, about how
Yeah,
to,
I was wondering, can I ask some questions just in general about like astronomy?
absolutely you can, but I'll just, if you don't mind, just quickly check if anyone else has questions about like what we talked about first, and then I'm totally happy to. Okay, if not, you can stay and observe our conversation, I suppose, or feel free to enjoy the rest of your evening. Thanks again, everyone, for coming. Yeah, hopefully see you at another webinar soon. And I'll stop recording.
Okay.